the floor where they drop like bombs. Faceless voices running all the cons. Digital whispers in the binary night. No light, no face, pure sound, no sight. Stories unfold in the dark unscrolled. Echoes of silence, secrets untold. Waves crash loud in this audio cave. No mic, no fame, just the sound we crave. Tune and turn up, let the silence break. Raw, unfiltered, hear the earthquake. No mic needed, just a vibe that's real. Faceless words you can touch and feel. In shadows, voices untamed. No need for spotlight, no claim to fame. Just a beat of life in a stream of thought. Every word a punchline, no need to be taught. Just listen close, no visuals needed. Raw conversation, unprocessed, unseated. Feel the pulse in every sentence said. No distractions, just thoughts in your head. Whispers of the streets, rumbling through. Faceless yet vivid, a world in view. No mic, just souls, connecting in flow. Pure and raw, let the rhythm go.
I regard the whole of arithmetic as a necessary, or at least natural, consequence of the simplest arithmetic act, that of counting, and counting itself as nothing else than the successive creation of the infinite series of positive integers in which each individual is defined by the one immediately preceding. The simplest act is the passing from an already formed individual to the consecutive new one to be formed. The chain of these numbers forms in itself an exceedingly useful instrument for the human mind. It presents an inexhaustible wealth of remarkable laws obtained by the introduction of the four fundamental operations of arithmetic. Richard Dedekind. Richard Dedekind (1831–1916) was a prominent German mathematician who made significant contributions to abstract algebra, particularly ring theory, algebraic number theory, and the foundations of the real numbers. Richard Dedekind was born on October 6, 1831, in Braunschweig, Brunswick, a city in the Duchy of Brunswick, which is now part of Germany. His father, Julius Levin Ulrich Dedekind, was an administrator at the Collegium Carolinum in Braunschweig, and his mother, Caroline Henriette Dedekind née Emperius, was the daughter of a professor at the same institution. Richard was the youngest of 4 children. He never used his first name, Julius, as an adult. Dedekind's early education took place in Braunschweig. From the age of 7, he attended school there. Interestingly, mathematics was not his initial primary interest. He later attended the Martino Catherineum, a good secondary school where he studied sciences, particularly physics and chemistry. However, he found the logical structure of physics to be less precise than he desired, which led his attention to turn towards mathematics. In 1848, at the age of 16, Dedekind entered the Collegium Carolinum. This institution served as an intermediary step between high school and university, providing him with a solid foundation in basic mathematics, including differential and integral calculus, analytic geometry, and the foundations of analysis. This prepared him for more advanced studies. In the spring of 1850, Dedekind moved to the University of Göttingen, which was then a significant center for scientific research in Europe. There, he studied number theory under Moritz Stern. A particularly influential figure during his time at Göttingen was Carl Friedrich Gauss, one of the most renowned mathematicians of all time. Although Gauss was nearing the end of his career and primarily teaching at an elementary level, Dedekind had the privilege of attending some of his lectures, including one on the method of least squares, which Dedekind later remembered fondly. In 1852, Dedekind completed his doctoral dissertation under Gauss, titled Über die Theorie der Eulerschen Integral, on the theory of Eulerian integrals. While this thesis was a formal requirement, it did not yet reveal the depth of mathematical insight that would characterize his later work. Dedekind was Gauss's last doctoral student. Realizing that he still had areas in advanced mathematics where he needed further knowledge, Dedekind spent 2 more years in Göttingen, qualifying as a university lecturer in 1854. During this period, he lectured on probability and geometry. He also studied with Peter Gustav Lejeune Dirichlet, who became a close friend and collaborator. Dedekind also dedicated time to studying elliptic and abelian functions to strengthen his mathematical understanding. Notably, he was the first person at Göttingen to lecture on Galois theory, demonstrating an early interest in abstract algebraic concepts. Around this time, he also began to recognize the fundamental importance of the concept of groups in algebra and arithmetic, ideas that would later become central to his own groundbreaking work in abstract algebra. Okay, here's a concise summary of Dedekind's work in the 1860s. Professorship, secured a stable position in Braunschweig, allowing focused research. Real number origins. Initial ideas for Dedekind cuts emerged while teaching calculus. Galois awareness, early appreciation and lecturing on Galois theory. Dirichlet's influence, extensive editing of Dirichlet's number theory lectures, deeply impacting his thinking. Ideal theory roots, grappling with issues of unique factorization in algebraic number theory, the precursor to his theory of ideals. The 1870s marked a period of significant intellectual output and the publication of some of Richard Dedekind's most transformative contributions to mathematics. Having established himself as a professor at the Brunswick Polytechnicum, he was able to dedicate considerable energy to his research, leading to breakthroughs that would reshape the landscape of analysis and algebra. A pivotal moment in this decade was the publication in 1872 of his seminal work, Stetigkeit und Irrationalzahlen, Continuity and Irrational Numbers. In this relatively short but profoundly influential treatise, Dedekind provided a rigorous and purely arithmetic definition of real numbers. Dissatisfied with the reliance on geometric intuition that characterized existing understandings of the continuum, he introduced the concept of the Dedekind cut. This elegant idea involved partitioning the set of rational numbers into 2 non-empty sets, where every element of the lower set is less than every element of the upper set. Dedekind meticulously demonstrated how each such cut uniquely defines a real number, whether rational corresponding to a cut where the upper set has a least element or irrational where the upper set lacks a least element. This construction provided a solid foundation for the real number system, essential for the rigorous development of calculus and mathematical analysis, effectively arithmetizing these fields. Throughout the 1870s, Dedekind's engagement with algebraic number theory, heavily influenced by his earlier work editing Dirichlet's lectures, continued to deepen. The problem of the failure of unique factorization into primes in rings of algebraic integers remained a central concern. This persistent issue motivated his development of the theory of ideals, a concept that would provide a powerful new lens through which to understand divisibility in these more complex number systems. While the full articulation of his theory of ideals evolved over several editions of Dirichlet's Facelesslingjutsu über Zahlentheorie, the core ideas were taking shape during this decade. He recognized that by considering special subsets of these rings, which he termed ideals, he could recover a form of unique factorization at the level of these ideals. A non-zero proper ideal could be uniquely expressed as a product of prime ideals, thus restoring a crucial property that was lost when working with individual algebraic integers alone. The supplements to the second 1871 and third 1879 editions of Dedekin's book were instrumental in disseminating his evolving ideas on ideal theory, although the most comprehensive presentation would come later. These early expositions laid the groundwork for the abstract algebra of the 20th century, introducing a new way of thinking about algebraic structures and their properties. The 1870s, therefore, were a period where Dedekind not only provided a rigorous foundation for the real numbers but also fundamentally reshaped the study of algebraic numbers through the nascent development of his theory of ideals, marking a turning point in the evolution of modern mathematics. Throughout the 1880s, Dedekind continued to refine and promote his theory of ideals, primarily through the subsequent editions of Dedekin's Facelesslingjutsu theory. The third edition, appearing in 1879 but significantly impacting the discourse in the 1880s, further elaborated on the power and utility of ideals in understanding the arithmetic of algebraic number fields. His approach provided a more abstract and general framework that moved beyond specific number systems and laid the groundwork for the development of abstract ring theory. Dedekind's work emphasized the structural properties of these algebraic objects, shifting the focus from individual elements to the properties of sets and the relationships between them. This abstract perspective proved incredibly fruitful and would have a profound impact on the development of modern algebra in the 20th century. While he continued his professorship at the Brunswick Polytechnicum, the 1880s were a period where his ideas reached a more mature and widely disseminated form, solidifying his reputation as a leading figure in the foundational and abstract areas of mathematics. His work during this decade provided essential tools and concepts that would be central to the progress of both analysis and algebra in the years to come. Throughout the 1880s, Dedekind continued to refine and promote his theory of ideals, primarily through the subsequent editions of Dedekin's Facelesslingjutsu theory. The third edition, appearing in 1879 but significantly impacting the discourse in the 1880s, further elaborated on the power and utility of ideals in understanding the arithmetic of algebraic number fields. His approach provided a more abstract and general framework that moved beyond specific number systems and laid the groundwork for the development of abstract ring theory. Dedekind's work emphasized the structural properties of these algebraic objects, shifting the focus from individual elements to the properties of sets and the relationships between them. This abstract perspective proved incredibly fruitful and would have a profound impact on the development of modern algebra in the 20th century. While he continued his professorship at the Brunswick Polytechnicum, the 1880s were a period where his ideas reached a more mature and widely disseminated form, solidifying his reputation as a leading figure in the foundational and abstract areas of mathematics. His work during this decade provided essential tools and concepts that would be central to the progress of both analysis and algebra in the years to come. The 1890s saw Richard Dedekind, already a well-established and highly respected figure in mathematics, continue to refine and consolidate his earlier groundbreaking work, although he published less new material compared to the preceding decades. A significant event was the publication of the fourth edition of Dedekin's Facelesslingjutsu theory in 1894, which Dedekind meticulously edited and to which he added further supplements. 1 These supplements provided even more comprehensive and mature expositions of his theory of ideals in algebraic number fields. By this point, his approach to ideal theory was becoming increasingly influential within the mathematical community, and these later editions of Dedekin's work served as a key vehicle for disseminating his ideas to a wider audience. While he may not have introduced entirely new foundational concepts on the scale of Dedekind cuts or the initial formulation of ideal theory, the 1890s were a period of continued reflection and refinement of his existing theories. He likely engaged in ongoing correspondence with other mathematicians, further clarifying and solidifying his ideas. While Richard Dedekind passed away in 1916, his direct publication of new mathematical work in the 20th century was limited. His foundational work from the 19th century served as a cornerstone for many developments in abstract algebra, number theory, and analysis throughout the 20th century. His rigorous definition of the real numbers through Dedekind cuts became the standard foundation for real analysis taught in universities worldwide. This arithmetization of the continuum provided the necessary logical underpinning for calculus and subsequent advanced analytical theories. Furthermore, Dedekind's theory of ideals revolutionized abstract algebra and algebraic number theory. His concept of ideals provided the crucial tool for understanding the arithmetic of algebraic number fields, where unique factorization of elements often fails. This framework was essential for the development of class field theory, a central area of algebraic number theory in the 20th century. The abstract notion of a ring and ideals within it, pioneered by Dedekind, became fundamental concepts in the burgeoning field of abstract algebra, influencing the study of modules, fields, and other algebraic structures that were extensively explored throughout the century. The above comparison of the domain R of rational numbers with a straight line has led to the recognition of the existence of gaps, of a certain incompleteness or discontinuity of the former, while we ascribe to the straight line completeness, absence of gaps, or continuity. In what then does this continuity consist? Everything must depend on the answer to this question, and only through it shall we obtain a scientific basis for the investigation of all continuous domains. Richard Dedekind.
Mics on the floor where they drop like bombs. Faceless voices running all the cons. Digital whispers in a binary night. No light, no face, pure sound, no sight. Stories unfold in the dark unscrolled. Echoes of silence, secrets untold. Waves crash loud in this audio cave. No light, no fame, just the sound we crave. Tune in, turn up, let the silence break. Raw, unfiltered, hear the earthquake. No mic needed, just the vibe that's real. Faceless words you can touch and feel. Hidden in shadows, voices untamed. No need for spotlight, no claim to fame. Just the beat of life in a stream of thought. Every word a punchline, no need to be taught. Just listen close, no visuals needed. Raw conversation, unprocessed, unseated. Feel the pulse in every sentence said. No distractions, just thoughts in your head. Whispers of the streets, rumbling through. Faceless yet vivid, a world in view. No mic, just souls, connecting in flow. Pure and raw, let the rhythm go. Pure and raw. Pure and raw. Turn up, let the silence break. Raw, unfiltered, hear the earthquake. No mic needed, just the vibe that's real. Faceless words you can touch and feel. Tune in, turn up, let the silence break. Raw, unfiltered, hear the earthquake. No mic needed, just the vibe that's real. Faceless words you can touch and feel. Pure and raw.
Okay.